Hi, this is Dr. R. Vijay Chandra, working as a professor in Nanda College of Technology, Aero. So, in this video, let's see about random variables. So, random variable is nothing but a value determined by the outcome of a random experiment. There are two types of random variables, that is discrete random variable and continuous random variable. So discrete random variable means it takes only a finite or countable number of values. For example, when three coins are tossed together, the number of heads obtained is the random variable x, which takes the values 0, 1, 2, 3, which is a finite set, of course. Such a variable is a discrete random variable. Next one, continuous random variable. Continuous random variable means which can take any value between certain limit or interval. Right? Example, the height of students in a particular class lies between 4 feet to 6 feet. You write this as capital X equal to set of all x such that 4 less than or equal to x less than or equal to 6. That is, this x value takes any value in between 4 and 6. Right? So the next example is maximum life of electric bulbs is 2000 hours. For this, the continuous random variable will be capital X equal to set of all x such that x lies between 0 and 2000. Next, the x be a random variable which takes the values x1, x2, etc. xn say, which each of these values we associate a probability value capital Pi, which is equal to P of x equal to xi, I varies from 1 to 3, etc. xn. This is called a probability of xi. This capital Pi is called a probability of xi when it satisfies the two conditions. The first condition is Pi is greater than or equal to 0. That is, Pi, Pi's are all non-negative values. The second condition is the total probability equal to 1. That is summation Pi is equal to 1. Right? So if these conditions are satisfied means Pi or P of xi is called the probability mass function. Then the ordered pair x comma p of x is called the probability distribution of the random variable. This table shows that capital X is the random variable, that is x1, x2, x3, etc. xn. These are the random variables. P of x equal to x, that is p of x1, p of x2, etc. represents the corresponding probabilities of x1, x2, etc. Right? If a random variable is discrete in general, its distribution is also discrete. Right? So, capital F of x, that is cumulative distribution function, is written as P of x less than or equal to x, where this x lies between minus infinity to plus infinity. Then capital F of xi is written as summation Pi, that is probability. Pi means P of x is equal to xi, right? Where this xi less than x. So capital F is nothing but a distribution function or cumulative function. Probability, next we see the probability density function. Right? It is written as PDF. A function small f is said to be probability density function of a continuous random variable x if it satisfies the following properties. The first one is if of x is greater than or equal to 0, that it is non-negative. Then second one is f of x equal to integral minus infinity to infinity f of x dx equal to 1. Next. We all know that p of x is equal to a, which is equal to integral a to a f of x dx. The value of integral, the same limits are given means the integral value is 0. Hence, p of a less than or equal to x less than or equal to b is equal to p of a less than x less than b equal to p of a less than or equal to x less than b equal to p of a less than x less than or equal to b. These are equal. Then we know that P of A less than x less than B equal to integral A to B f of x dx. Then next we see distribution function for continuous random variable. Right? So far we have seen the discrete random variables. Here continuous random variable distribution function for continuous random variable. So capital F of x equal to minus infinity to x f of x dx, which is equal to p of x less than or equal to x, where this capital X lies between minus infinity to infinity. Then capital F of b minus f of a is written as integral a to b f of x dx. This is equal to p of a less than x less than b. These are the properties of distribution function. Capital XB either discrete or continuous random variable. Then the first property is capital F of x is a non-decreasing function. That is, it is an increasing function. Then this distribution function capital F of x lies between 0 and 1. Then f of minus infinity equal to limit x tends to minus infinity, f of x takes the value 0, f of infinity takes the value 1. If f of x is the cumulative distribution function of a continuous random variable with PDF f of x, then f dash of x equal to f of x. Next we see an example. Here x values are given and their corresponding probability values are also given. So we are finding the value of A and the probability values, and also finally we find the cumulative distribution function of x, right? So let's see one by one. So in the first question, determine the value of A. So for finding the value of A, so we take the concept summation PA is equal to 1. So we all know that total probability is equal to 1. So that is written as summation PI is equal to 1. So therefore, we add all the probability values A plus B, 3A plus 5A plus etc. up to 17A. So these values are equal to 1. So that is the sum of these values is 81A, which is equal to 1. So from this, the value of A is 1 by 81. Right. The next subdivision is we are finding P of x less than 3. So P of x less than 3 means we have before 3 we have 3 values 0, 1, 2. So just add these probabilities. So P of x equal to 0 plus P of x equal to 1 plus P of x equal to 0. So write its corresponding probability values A plus 3A plus 5A. So it is 9A. So now you write the value of A here. It is obtained as 1 by 81. So 9 into 1 by 81. So the answer is 1 by 9. So similarly we find P of x less than or equal to 3. X less than or equal to 3 means we start from the first value 0 and we write up to 3 because it is given less than or equal to. So P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2 plus P of x equal to 3. Right? So add the values A plus 3A plus 5A plus 7A. So the answer is 16A. Now you substitute the value for A here. So that the answer is 16 by 81 because A is equal to 1 by 81. So next subdivision is P of x is greater than 7. So x is greater than 7 means we have just only one value, that is 8. So right here P of x is equal to 8. So probability value P of x is equal to, when x is equal to 8, its probability is 17A. A value is 1 by 81, therefore 17 by 81. Then let's see the next one. P of 2 less than or equal to x less than or equal to 5. So you start from less than or x lies between 2 to 5. So here you have less than or equal to. So you start from 2 and stop at 5. Right? So P of x equal to 2 plus x equal to 3 plus P of x equal to 4 plus P of x equal to 5. So similarly we have written its corresponding probabilities 5A plus 7A plus 9A plus 11A. So the answer is 32A. Write the value of A here 1 by 81. So the answer is 32 by 81. Next we see P of 2 less than x less than 5. So in between, x takes the values between 2 and 5. So just exclude the values 2 and 5. So in between value means x equal to 3 and x equal to 4. So P of x equal to 3 plus P of x equal to 4. So write its corresponding probabilities 7A plus 9A. So the answer is 16A. Just replace A by 1 by 81. So the final answer will be 16 by 81. Hope this will be useful to you. Thanks for watching.